Let's talk area of parallelogram and triangles. Before we focus on the parallelogram and the triangle, I want to go through all the figures we're going to talk about today and tomorrow. Do you know any of these formulas? I guess you could look back on your formula sheet and cheat, right? But do you know any of these formulas right, without even the formula sheet? What do you know, Tanner?
1/2 base times height.
Which is triangle. Yep, triangle. So let's fill that in first. 1/2 base times height. The formula doesn't scare me. What scares me is if I give you a triangle, can you figure out what the base and the height is if there's like 4 values on it? Can you figure out what the base and the height are? So let's talk about just a regular non-right triangle. Let's talk about a triangle that's not right. Height. Not a big fan of that word because we have a fancier word this year, don't we, honors kids? Height. Another vocabulary term. Griffin. Altitude. Yeah, so what's an altitude do? Forms A? Just forms A? Right angle. All right, so it has to start at a vertice and be perpendicular to the opposite side. So there's the height. How many heights are in a triangle? Well, 1 height all around, but I could draw it how many different ways? 3 different ways. And wherever that height is drawn to, that side's the base. We count as the base. So everyone see I drew my height to this side right here. That side would be considered my B value, the base. I hate the whole base equals bottom. No, it doesn't. If I drew the height from this vertice across, now that's my base. Height always drawn to the base. Height always drawn to the base. All right, go to my right triangle now. Base and height, already there. It's already there. What do I mean? What do I mean my base and height are already drawn? In a right triangle, give me another vocabulary term for the base and the height. They're known as the what of the right triangle? Hi, Avery. The legs. So when you're dealing with a right triangle, the base and the height are the 2 legs. All right. You know any others up here, superstars? You know any other formulas? John?
Rectangles, length times width.
Yep, some people say base times height, which is fine with me. I'm going to use length times width. And those are literally the 2 sides, whatever you consider length and width, I guess. All right, yep. Hi, Serena.
Circles, pi r squared.
Yep. Remember, circumference was pi d. Cherry pies are delicious. A, apple pie is R2. You like that one, kids? Pi r squared. What's the R stand for? Ooh, thank you. Radius length. Hasn't been that long. Those are usually the 3 most popular ones people know without looking. Any others? All right, let me go backwards and we'll build up to the...
Parallelogram is base times height. So.
I was going to lead up to that. That was today's topic. But yeah, I could put that in now. Base times height, parallelogram. Yeah. Be aware, sometimes the height is not inside the parallelogram. Because take a look. Is it really possible for me to draw a height from this vertice inside the parallelogram? Is that going to form a right angle? That going to form? Nope. I don't think there's any line I can draw inside that's going to form a right angle. So instead, you may see a height drawn outside. Where would my base be then? Wherever the height is drawn to, but the base has to be an actual side. Hey! Base? No, that's not even a side. This right here would be your base. Right there. That would be your base. So base times height. Nobody knew the trap, huh? The trapezoid. 1/2 H for height, right? Parallelogram. If I draw a vertice perpendicular to the opposite side, it's got a height. times, ooh, ready for this one? B1 plus B2. What do you think I mean in B if I'm talking about a trapezoid? And it's got two of them. Bases, good. And those are the parallel sides, right? We refer to the bases as the parallel sides. All right. So 1/2 the height times the sum of the bases. And we're also going to talk about rhombus tomorrow. We're not going to talk about kite, but just in case it comes up maybe on the regents, I don't think it should, but in case, it's the same formula as the rhombus. 1/2. Let's see if you can figure out what this variable means. D1 times D2. What the heck would I mean if I'm referring to D in a rhombus or a kite? Something that starts, somebody said diameter period 2 and I was ready to lose it. I don't think a kite has a diameter or a rhombus has a diameter. Something that begins with the letter D, a part of a rhombus or kite that we've definitely talked about. Hi, Lauren. A diagonal, thank you. Oh yeah, that starts with D. Diagonal, yes. Oh, this is going to make me cringe even more because we have a regents in less than 2 months. Are the diagonals congruent in a rhombus? Are they congruent in a rhombus? 50-50 shot here. They are not. What figure are they congruent in? Rectangle, square. They're not congruent, but they are. We may need, we're not going to discuss it today, but we will tomorrow, but they are perpendicular. There you go. All right. So those are the ones we're going to be going over the next 2 days. Today, our focus is on parallelogram and a triangle. And you're probably like, wow, this is going to be an easy day because BH, 1/2 BH. I wish it was going to be that easy. Here you go. Number 1, I got a parallelogram. Find me the perimeter first. Perimeter, and then we'll talk area. So perimeter first. You guys know perimeter is all the sides added up. Well, I got one side of 23, and I have no information about the other 3 sides. Well, you guys are stout, you're studs. What do you know about a parallelogram? Big property. I think probably the first property I showed you of a parallelogram. I only know one side. Tell me something else you know. You should know another side. Let's go right to it. First one today. Whoa, 14. Oh, of course it would be. 21. What else do I know about a parallelogram? If that's 23, opposite sides are congruent. Another side is 23. I still have 2 more sides I got to add up. And I don't know anything about either one. But I did give you 7 and 24. So we could use what to find a side? 21 again. Let's go. Thank you. Pythagorean theorem, everybody. Not off the hook yet. Where's A and B and C? What are you plugging in for those values? 8?
24 and 7 are A and B.
Good. And then we're solving for C. Perfect. So what do we end up with? C equals, what do you guys have, 25? So those are my missing values in the parallelogram sides for the perimeter. 50 and 46 give me 96, 96. Oranges, apples, corn shackles. What do we got here? Thank you. What is a corn shackle? Any issues? What about the area? Again, simple formula to remember, right? BH. But do you know what B and H and are? Because I'm not just going to give you a problem with two values and you just take those two and plug it in. All right? I got 3 up there, 2 of which are the height and the base of this parallelogram. Height. It's got to be perpendicular, right? It's got to form a right angle. So what's the height of this parallelogram I gave you? Whew, 8 again. Let's go. Doubles. Darn right it is. 24. Height drawn to the base. Height drawn to the base. Don't tell me it's 7 either. That's not part of the parallelogram. When you say base, I need an actual side length. So it's being drawn to a base length of 15? 23. Not 30. 30 is not the side length. It's 23. And one other new thing I got to show you, probably not new to you guys, right? Yeah, I get 552. What's going to change now? Feet squared. I don't square the 552, but anytime I do area, my units are always squared. Yeah. Heads up. Not too bad, right? You ready to get tougher? An old friend of ours. Yes, are you starting to see it already here? Whew, look at part A. Look at that degree measure I put in there for you. 45? Okay. All right. Just find the area. No need for perimeter on this one. Just find the area. BH, right? BH. You see the height, but you don't know it yet. We see the height, but it's missing. Can you at least tell me the base length it's drawn to? It's not 9. It's not 9. It's got to be the whole side. Got to be the whole side. So what's the base that height is drawn to? Ooh, 8. Oh, 8. Let's go.
9.
Not.
Wait. What was the question?
The height is drawn to a base length of
Oh, 17.
17. There you go. Everyone ready to find the height with me? The height is part of a 45, 45, 90. So let's review the rules here. What do you know about the sides across from the 45s? They're congruent. So legs are congruent. And I'm just writing this down to remind people. Legs are congruent. And then anybody remember how to find the hypotenuse? Leg times 2, square root of 2, not square root of 3. That's coming up. Even I know I don't need the hypotenuse. So now using those rules, I see the 9 is across from the 45 and so is the height. So what's the height measure then? 3. Also 9. 2 legs are congruent. All right, stop. Pencils down. Pens, pencils down. You freeze. Didn't remember my rules. Is there another way I could get to 9 for the height? Yes. This is a right triangle, isn't it? If I go from that given 45, H, opposite, adjacent, or hypotenuse to it? It's opposite. The 9 is adjacent. If you know the opposite and the adjacent side, which one of the 3 ratios could I use? Tangent. So I could also do tangent instead, if you totally freeze on your rules. All right? As long as it's a right triangle, which it will be. And what am I looking at? 153 yards? Square yards? Oh, we can't do 45, 45 without remembering 30, 60, 90. There's the height. Start me off here. What's the height drawn to? A base length of? What's the base length in this one? Oh, 4. 32. All right, everyone ready to find the height with me? All right, you remember our rules here. In a 30, 60, 90, you have a shorter leg, which is across from the 30. You have a longer leg across from the 60, and you have a hypotenuse. Anybody remember how to find the hypotenuse? Joa?
This is short leg times
2 times short leg. Yep, I'll do SL. And then how'd you find longer leg? How'd we find the side across from 60? It's pretty important here, Matt.
Shorter leg times square root of 3.
Square root of 3 times the shorter leg. Good. So I have 12 as my shorter leg here, everyone. 12 is the shorter leg. I'm looking for the longer leg, the one across from 60 here. So what do you got here? What is my longer leg using my rules? Hey, 3, back to you, Eva. 12 square root 3. Yep, good. And lucky for you guys, I asked you to round to the nearest tenth. So I can just plug all that in my calculator and round to the nearest tenth. Any questions? Be prepared for a heavy dose of that tonight. 30, 60, and 45, 45 triangles. If it's hey, also, okay, let's say it's something you're unfamiliar with tonight. Maybe I change that to 32 degrees. Now, what do we have to rely on since we don't have rules for 32? Sine, cosine, tangent. Okay? So if it's something you're unfamiliar with, it's not 30, 60, or 45, 45, no excuse. We could still use sine, cosine, tangent. All right. All right, we're good with the parallelogram. You ready to go for a triangle? And speaking of old friend, there he is. He will be much more a part of your life here in the fourth quarter before we reveal Big Al's identity at the end of the year. A little celebration. He owns a lot of stuff. Windmills, silos. He's got a triangular plot of land here in example 3. He's got a rectangular garden in number 4. Unbelievable, this guy. Unbelievable. All right, so basically he's combining 2 triangular gardens here in number 3. 2 of them. BCD and ABD. So how big is the combined one now? Triangle ACD. What is the area? Remind me and your classmates one more time, area formula for a triangle. Hey, 4, area formula, Griff. Yep. Just be careful there. I always worry going from parallelogram to triangle, right? I got the BH part, but now I got to put 1/2 with it. This is a right triangle. A right triangle. I already know where the base and height are. They're the 2 legs. So what? Give me one value I already know for the formula. 10, what's one value I already know?
15.
15, yep. So 1/2, 15. The other value you guys need to find is AC. That's the other leg. AC. So take a minute, think it over. I'll ask somebody here, after you get time to think, how can I figure out what the length of AC is so I can finish off my area formula? See a lot of typing on the calculators. What's your approach to get AC? Oh, 8 4-bagger today.
I did that with the ABD.
Good. So first I'm going to go Pythag. Now this will find what? AB?
Yeah,
And then what are you doing with that?
I'm adding it to 16.
Darn right you are. There we go. We're going to find AB using Pythag, add it to 16, and then plug it into my area formula. Good work, kids. Too bad you don't get a nice pretty number here when you solve for AB, right? Make sure 25 goes in for C squared. Actually, no, you do here, right? It's the next one. It's the next one. Relax. I'm thinking of. Because that's 3, 4, 5. So that's going to be what? 20? Have some self-respect. How many of you are plugging in 20 right now into the formula? Come on, you're better than that. We're plugging in 36. $270 square yards. I think that was an old Regents problem. I think. I definitely know this next one is. Questions? All right, find the area of this garden. Garden's a rectangle where we already know length or width, whatever you're calling the 6 there. 6 times, you're on the hook for the other side. You're on the hook for the other side of that rectangle. So doing a little Pythag first. This is where it doesn't come out to be pretty, right? So we're doing 25 squared plus 10 squared equals c squared. We're getting 725 equals c squared. All right, when you take the square root, it's not a perfect square. What are you doing to that number before you plug it in here? Yeah, the answer is absolutely nothing. You're not rounding it. You're not done with the problem. You're just taking whatever that is and plugging it, all of it, not a couple numbers after the decimal, all of it into the area formula. Multiply it by 6, then you can round to the nearest foot, square foot. 162 square feet. Anything from you guys? All right, so we did parallelogram, triangle. I'm going to go down a different path right now. I know this topic comes up on the Regents exam, and it does deal with area, so it's a good time to do it. Do they talk about this in science or no? Population density? Density, different than population. Yes, no? All right, so in a nutshell here, population density. It is a formula I'll get to in a second. Number of people in an area relative to its size. So for instance, my classroom right here, Mrs. Lynch next door, we both have the same size classroom. Same exact size. Except, I don't know how many students she has in there. I'm going to say we have more students. This class has a higher population density than her class. Same exact classroom size. Why? I have more kids in here than she does in the same exact area. So my population density would be higher than hers because I have a bigger population in the same size classroom. Okay? If you think states, we'll get to in a second, play a little game. If you think states, what state has a high population density? Some state where it's a lot of people in a small spot. What has a low population density? Huge state, not many people there. Okay, so the size of the state doesn't dictate if it's high or low or not, right? If it's a high population density. Because what do you think is a big state? Texas? It's not number one for population density. I don't even think it's in the top 10. Okay, what's another big state? Alaska. I can tell you it's not even top 40 as far as population density goes. Why? Because it's a big area with very few people. All right. How do you calculate population density? You take the population and divide it by the area of the land. So what I'm going to do here first, I got the 5 boroughs in New York City here, how many people they have in it, and the land area. You take a quick glance at this and you're like, hi, Queens, most people, right? But I guarantee it's not going to have the highest population density. You'll see why here at the end. So I think the easiest way to do this is let's add a fourth column onto here. So we're just not doing calculations all over your paper. And let's just make this 4th column population density. And let's figure out which borough has the highest and which borough has the lowest density. So you guys have the formula now, which you're responsible for. It's not on the formula sheet. So we're going to take the population for each one, divide it by the land area, and get our population density. And yes, I like to write out the full decimal just in case there's a close tie for first and second, last and second to last. I can at least compare it with the decimals if it does come close. Highest? Manhattan, yep. And the lowest population density out of the 5? Staten Island. I always like to visualize this too and give you guys a visual of what the heck these numbers actually mean. Take it this way. Let's say I have a square. Visualize a square that's 1 mile by 1 mile. So pretty decent sized square, all right? 1 mile by 1 mile. In Manhattan, you're fitting about 67,000 people in that square. Okay, so if you've ever been to the city, Manhattan in particular, if you've ever seen pictures of it, videos, looks pretty packed. And there you go. Basically a 1 by 1 mile square, you're packing 67,000 people in there. Right, that's how dense it is. All right, quick game. 50 states. The state with the highest population density. So we're thinking states, not that large, but definitely a lot of people packed in. Yes, Jonah?
New Jersey.
Did you look that up while we were doing it? It is New Jersey. Yep. Followed by basically all the New England states. Connecticut, Massachusetts, New York's in there. Lowest population density? It is Alaska. And I'll show you this because I think it's very odd, but here's a list of the top 50 here, or 50. They got District of Columbia and Puerto Rico in there as well. So New Jersey, we're talking about that 1 by 1 mile rectangle. New Jersey, about 1,263. And then you go all the way to Alaska, 1.3. 1.3 in there. And I'm sure that doesn't mean actual people. It's got to be in thousands or wherever, I'm sure. But there you go, 1.3. All right, so there you go. Wyoming's up there, Montana, as far as low population density, New Mexico. So pretty big states with not too many people. And then, like I said, down below, you start getting to all the New England states. Maryland, Delaware, Mass, Connecticut. All right. What did we say? Texas earlier? There you go, Texas. 30th out of 50. All right. Questions about population density? And then finally, we'll end it in class. How's it show up on the Regents exam? Just like this problem here from 2016. This is how it showed up in the Regents exam. I got 2 Petri dishes up here. One has 40,000 bacteria. The other has 72,000 bacteria. Which one's got the higher population density? And again, we just can't say, oh, it looks like A because I don't know why. Right? Give me some numbers that show me why A or B is going to have the greater population density. So let's take Petri dish A first. You guys have a formula for population density, don't you? Population over land area. We already know the population, don't we, of bacteria? It's 40,000. Wait a second. Land area? I didn't give that to you like the Burrow question. That's on you now. What shape is the Petri dish in? Circle. I know this wasn't today's topic, but I did give you the formula for a circle, right? Pi r squared. There's your area. It's a circle. Find the area of that Petri dish. I hope we're not plugging in 51 though, right? R for radius. What are we plugging in instead of the 51 for radius? 3? Eva? Good. Cut it in half. 25.5 squared. I worry about what you're typing in your calculators now. If you're pulling this on me right now, 40,000 divided by pi, where is it there? Pi times 25.5 squared, you're not going to get the right answer. Here's why. Your calculator is just going to divide by what? What's the first thing after the division symbol? It's just going to divide by pi and then multiply it by 25.5 squared. I want to make sure it divides by the whole thing. How can I adjust this? 40,000. If you're going to do the division symbol, what do I need to put there? Parentheses, yes. Or hey, here's an idea. All of you guys have these beautiful calculators. How about we just use the fraction template too? We don't even have to worry about parents. All right, if we use the fraction template. But if you're not, Make sure it's parentheses pi times 25.5 squared. Now we'll get the right answer. 19 point change. And then go ahead and do the same thing for Petri dish B. $72,000 divided by pi r squared. What are you using now? Not 75 but 37.5 squared. And population density of Petri dish B would be 16.297. So we could see, hey, Petri dish A, highest density. Real quick, look at the bottom of your notes there. You will see number 31 out of the book tonight, number 33 out of the book tonight. Graph, not on a ghetto graph here, where you make up on your by hand on an actual graph paper. I got some slices up here. If anybody needs any on your way out, pick one up. Okay, but number 33 is done on a graph, piece of graph paper tonight. Make sure you do the 2 in your packet, page 6, population density.